Welcome to our backyard. This is the Backyard Philosophy Podcast. We are two friends having a discussion after everyone else has passed out or gone to bed. Grab a drink and listen as we discuss everything from automation, space exploration, and why the meaning of life is 42. Mysterious diseases, underground trading networks, disappearing reefs, well-meaning tourism. It's not a dirt pit novel, and Numa isn't coming to the rescue. Today we're going to talk about coral reefs, problems, and hopefully solutions.
I must say, Nick, I am excited to talk about coral reefs. This is a subject, for some reason, I keep falling down the rabbit hole, and I thoroughly enjoy and thoroughly am worried about. First off, Nick, I want to ask what you're drinking. I'm drinking a Moscow Mule. I'm going a little fancy with the cocktail today. So how you doing, my friend, and what you drinking?
I also went with the cocktail today in honor of coral reefs. I'm drinking a mojito, a tropical rum drink. Rum is a pretty interesting backstory in the Caribbean, but I'm drinking it out of a Kenny Chesney glass, and I am feeling the island vibes, as they say.
It's funny enough that you say tropical, because that's mainly where coral are found. For those listening, there are four main types of reefs, and coral are usually found in those reefs. It is the fringing reefs, the barrier reefs, the atoll reefs, and the patch reefs. So the fringing reef tend to be near coastlines and islands, and if, Nick, you're drinking that tropical drink on an island, you might be able to see one. You have the barrier reef, which I assume most people are familiar with, like the Great Barrier Reef in Australia, which tend to be parallel to coastlines, but be in deeper waters compared to the fringing reefs. You have the atoll reefs, which usually are in like lagoons or swamps or in underwater volcanoes, so they're a little bit more niche reefs. And then you have the patch reefs. Now these are reefs that are kind of in between the zones of the fringing and barrier reefs. So not quite as shallow as right near the water, but not quite as deep as barrier reefs, which, again, I would love to be on a tropical island and to see the reefs. I would love to see them. But as Nick said, we're going to be talking about the problems and issues they are having today and some possible solutions. And I think a little background knowledge before I hand it back off to Nick is, what is coral? Now, coral are made up of two organisms. They're a two-organism system. You have polyps and algae. The polyps, if you think of the image of a coral, they're like the little bumps you see. Those are polyps. And then the other half is algae, called, as y'all know, hopefully by listening, I'm not the greatest with my words, but let me try to pronounce it anyhow. So xanthothe, which is a type of algae. I believe I said that actually not half bad. I'm proud of myself.
I think it's pretty good. Now I'm probably going to mess it up, but I think it's zooxanthale, but both of us could be wrong, so don't hold that against us.
And this is a very interesting two-part system. So the algae help feed the polyps, and the polyps give a home for the algae. Pretty much, coral is built on the skeletons of other coral. There's like a layer system almost, and it's a very symbiotic relationship. They need each other to survive. And it's not just each other that they need to survive. It's also majority of the world. An estimated 500 million people earn their livelihoods from the reefs. That comes from fishing, tourism, which we'll talk about a little bit later in the podcast, and 25% of all marine life in some shape or form depend on the reefs. 25% of the ocean. That's an amazing number. And they also help the people on land. Coral reefs help protect against waves and coastal erosion, and they have the ability to reduce wave energy up to 97%. And nearly 200 million people get that protection from reefs. The reefs have also given us medicine. The reefs are a very important system, not just the underwater ecosystem, but to our own lives. And it's a bit disheartening as issues and problems keep bewildering the reefs and keep making it harder for them to grow and spread.
Yeah, to tie in with what Mike's saying, the reef slowing down waves, so disappearing reefs reduce the wave impact less, so waves are bigger. Think about more during like a hurricane. You have larger waves that can devastate cities. The reef destruction coupled with like the mangroves, the loss of mangroves, and just the marshes that you see out on the Gulf Coast and the Florida coast there, just, that the tides, the brackish water tides where the redfish hang out, the red drum, when those are removed, you have a lot less biomatter, reefs and grass, and just a built up of sand and stuff to stop those waves. So hurricanes are getting more deadlier just because the waves have nothing to stop them. So they're at a higher velocity when they hit a shoreline than in years past when we had healthier reefs, and more mangroves and swampland to bring the waves. They say for the swampland side, not to get too far away from corals, but for each mile of each mile of marsh brings wave height down 1 foot. And when you build houses and stuff like that and tear that down, then your wave height is going to increase. Well, not increase, but it won't decrease from what it was on the ocean. So you're losing that protection.
So all these things are happening to coral reefs, of them disappearing, not growing, not being as healthy. So what is killing these coral reefs? What is happening to these coral reefs? Well, in short, humans. We have pollution, overfishing, global warming, and poisoning. Humans are very, very good at ruining a good thing, and unfortunately, we are ruining a good thing with the coral reefs. And throughout the podcast, we'll talk about all those problems, but one problem I want to start off with is plastic. Plastic is covering the coral reefs, and the amount of plastic is supposed to increase by 40% in the next 7 years. And that's an article coming out from 2018. Again, you can check out our sources on YouTube. We put them in the description. But plastic highly affects the life of a coral. When covered or draped in plastic, coral reefs' chances of becoming infected with diseases increase from 4% all the way up to 89%. And that's devastating. And hopefully some of you know or might not know, right now in the Pacific Ocean, there is a patch of plastic, spotted plastic pieces, the size of Texas floating in the Pacific Ocean. And every year, more and more plastic, both microplastic and large pieces of plastic, are added into our water systems. And that's poisoning the coral reefs, which is sad to say that our type of pollution is devastating them. And another type of pollution that is coming from the coral reefs, I want to touch on both plastics and this because they are intertwined, is runoff. Runoff from mainland, from islands and continents and countries. It's especially the fertilizer and other chemicals, more specifically nitrogen, that is poisoning the coral reefs, and something we might not think about, sunscreen. In 2016, divers off the coast of Texas and Louisiana saw some of this poisoning. The coral reef in this area was doing this thing called de-skinning, which just the name of it sounds awful. It's tissue that scientists may think that is becoming sulfur oxidizing bacteria, which is killing and affecting marine life. And as one person put it, is a blanket of death. And this is coming from erosion from the mainland of poisons getting into the water, or people just overusing sunscreen, like zinc oxide covering up the pores, or not pores, the mouths of the polyps that force them not to eat or affect the algae. And I would want to focus on these two subjects because those are things we can easily change and easily affect and help, and the average person can do right away. So, Nick, I've been babbling on a little bit. I assume you want to say something.
Well, just talking about like the nitrogen that's coming into the waters, a lot of that is coming from agriculture fields in the United States and other countries predominantly. The United States has a lot better regulations when it comes to that stuff, but I want to touch on why that's important and why we can't get that away, or how we could get rid of that. So we have buffers in the forest industry that are left around streams, and it's native habitat, or well, it's untouched. So a lot of times it's native trees with invasive species understory, because that's the way it goes. But that habitat is basically just a collection. It filters anything that happens above and keeps the water clean. Now, we don't have that in every state for agriculture because that's harder to regulate than the forest products industry. And farmers are agriculture. They use fertilizer, predominantly some kind of nitrogen based compound, to increase your yields. And it's an important tool for them because these farmers are competing against people from all over the world who may or may not use the same regulations. So I think it's important to, if we're going to say, one obvious solution would be to not use fertilizer. But if we're going to put that on farmers because they're going to bear the brunt of that, we also need to protect them in a way that says, hey, if they can't use fertilizer, we're not going to allow companies that or countries that do use fertilizer to input their goods in the United States economy, because then you're competing against superior goods, which is hard to do, and they're probably not as regulated as the United States. So if that's a topic that really like we needed to do to save the reefs, then I think that's a possible solution that I would be okay with instead of just screwing over the farmers.
Well, I don't think it's exactly the farmer's fault, because a big part, which I think is happening, is weather's unpredictable. And soon as farmers fertilize their soil with their nitrogen or whatever minerals they're using, it might rain. And that rain might cause a runoff. And that runoff might lead to the ocean. And it's been happening, and that's what they suspect happened off the coast of Texas. Sorry, Nick. I got to talk about Texas because it's dear to my heart. But it's kind of unpredictable what can happen with the weather. But if we put in some solutions to help the runoff or filter the runoff or just the amount of level of nitrogen, it could have a huge impact. It would stop coral from deskinning. And I don't actually implore you all to look what deskinning is, because it just turns this algae into like a brown muck. Like it looks like a swamp almost, but not a healthy one. And that coral reef is not supposed to look like that. Now, like I wanted to mention before, is runoff. That runoff is something we as individuals do with sunscreen. A lot of sunscreens are unsafe and not good for the environment. A lot of aerosol and lotions have like zinc oxide in them. And this zinc oxide can heavily affect coral. So if you have the means, I really wish that you guys use more natural and reef-safe suntan lotion. Now, you might think, well, the reefs aren't near me, it's not a big issue. Reefs span everywhere from the Gulf, Mediterranean, Africa, Australia. They're all around the world in many different locations.
And we didn't talk about these earlier, but there's even reefs in Norway. They're dark reefs they're way beneath the waterline, and we really don't know that much about them, so we don't completely know if sunscreen, other runoff like that, is affecting them. We barely know where they are, so we don't really know that much about them, but they are all over, and even if you're not in the tropics, they could just be off the coast from you, and we just don't know yet.
It's amazing to think that we know more about our solar system than we do the depths of our ocean. It's amazing. It's fascinating that we discovered a new type of coral reef in the north of Europe. Like, that's mind-boggling to me. And you can help it. Just wear safe sunscreen for the environment. And I mean, it might be $1 more, but your conscience is clear, and it really helps. And tying back a little bit with the plastic of just making sure you recycle or making sure you actually throw away your trash, because over time, the sun, the waves, the environment will break that plastic down and turn it into microplastic. And that microplastic will affect more and more coral reefs. It might drift. It might cover up very important plants. It might kill the very coral that houses the clownfish, which we all love from Finding Nemo, and we don't want those species to go extinct. It'd be really sad to see those gone. And it's simple stuff like that of making sure you're wearing the right suntan lotion, making sure you're picking up your trash and recycling. That would help so much with that. And going back to fertilizer a little bit, the runoff, as Nick said, first world countries tend to be decent at it. I wouldn't say good, I would say decent at it. But there's still so many unpredictabilities of, hey, we might get a tsunami, might get a hurricane. Some farmer who might be in deep South Carolina, not worried about runoff because he's so far away from the ocean, and a hurricane comes up, picks it up, and brings it into the ocean, it's going to affect the ecosystem. And I think that's something that we need to consider moving forward.
When we talked in the Fire podcast about weather and how unpredictable it was. I deal with this all the time in my job. Knowing when it's going to rain, where it's going to rain, what the wind is doing is crucial. And we get it wrong more often than we get it right, it seems like, or at least when your job is depending on it and you're going to go off that forecast. These are things we just don't know or don't completely understand. We can't model accurately. So it's not, it's not anyone's fault. I took a meteorology class in college, and it's really hard to predict the weather. So, it's not like there's a script that gets printed out and tells you what the weather is. You got to look at where the transport winds are coming from, what moisture is below you, and all these different things. And then you just make an educated guess. That's pretty much how it goes.
Those poor meteorologists, they're damned if they do and damned if they don't. They can't win. I feel so sorry for them. You hate them when they're right and you hate them when they're wrong. But switching things up a little bit, Nick, you brought up the weather a little bit, and I think we'll probably spend most time talking about it, but that's probably the main killing force of these coral reefs: global warming. Slowly and slowly, water is becoming warmer and warmer, and it's affecting this symbiotic relationship between the polyps and, let me try it one more time, zooxanthellae. I'm just going to call them algae. I probably butchered that. But when the water is increasing 1 degree Celsius per year or 1 degree Fahrenheit per year, it's changing that ecosystem. And coral's been trying to fight it, but they're losing. They're not adapting very well to it. And when the water becomes too warm, the coral will expel the algae to survive. They'll try to hold on as long as they can by doing whatever they can. And eventually they become bleached. Now, when we say bleached, it's a term to describe when a coral reef is not healthy. It's expelled its algae and looks white, bone white, like a graveyard white. And it does look like a graveyard. I implore you to actually look up the pictures of bleached coral. It's devastating to see all these bright colors, orange, green, blue, yellow, red, go from elaborate colors to starch white. And with the water warming up, and if the coral are without algae for too long, because the algae can come back, which is kind of good news, but unfortunately is becoming a little bit harder and harder to do. Without that symbiotic relationship, the coral reef dies.
Bleaching is in white band disease, which is a similar thing. It doesn't kill the entire coral, it kills parts of it. Like Mike said, is predominantly brought on by an increase in temperature. And they don't exactly know for certain if it's an increase in water temperature. There's also some evidence that it's an increase in the amount of light, the ultraviolet radiation that hits the corals. Because if you go to some of these bleached coral reefs, you'll find that the shaded portions of the reefs tend to have a lot better survivability than the ones exposed to the UV radiation. And that could be because of minute differences in water temperature, or it could just be because, due to whatever is going on in the atmosphere, an increased amount of solar radiation is penetrating and frying these reefs, because below 8 meters, which I had to check, is 26 feet. That's anything above that tends to get hit, but anything below that tends to be okay. Now, whether that's because at 1 atmosphere, I believe it's like 33.5 feet, that's where a third of your light or your solar radiation is absorbed. So everything's a little bit darker down there, but it's also going to be a lot more cooler down there.
Nick, one of these days, I need to sit down with you and teach you the metric system, the glorious metric system. It's far, far more superior than the imperial system.
Sounds like some communist bullshit to me, Mike.
Oh, we are going to have words after this recording of metric versus imperial, or pretty much like how the entire world's driving on the right-hand side and only a few countries hold out with the left-hand side. It's very similar conversation. But getting back on track before I go too far on the imperial system, y'all might think that coral is not surviving because it's not the survival of the fittest. It might be it's not adapting as fast as we mentioned, but you got to think and think. Coral in the past, so coral's been around for 400 million years-ish, somewhere around there, and has adapted to changing global temperature change. But because this global temperature is rapidly changing to a point where even coral can't keep up, So for over 400 million years, or around 400 million years, coral has been able to change with its environment. And all of a sudden it can't. It's sad to say, but again, it comes down to humans of us changing our environment too fast or not taking care of what Mother Nature gave us. And it's sad to think. So an important fact to bring into this is oceans absorb and store heat. So the oceans actually store and absorb about 90% of the planet's human generated gases. So everything humans produce, the oceans kind of absorb. And again, it's humans mixing with the pH, adding fertilizers, adding different components to the water, and I assume we'll talk about fishing pretty soon. Of that is changing the environment so rapidly that the coral can't keep up, which is it's sad because coral is, like we mentioned earlier in the podcast, so important to the ecosystem.
Yeah, and this differs from the fire podcast, how we talked about how we're seeing an increase in wildfires due to poor mismanagement. Well, I guess poor management, it would be mismanagement. This is an entirely different thing. I checked because the last coral, much like trees, has evidence of disturbances in the past, like how you can count the tree rings. Well, like Mike talked about, corals build upon themselves. So all those corals that died, they just become the seafloor and new coral grows over them. So you can actually go back and count the rate of coral death for the study I read was 2,000 years. And they've been dying at the same rate for those 2,000 years. So we have at least, can say for 2,000 years, corals had a pretty steady population. And we're seeing an increase in death. And most likely due to a warming climate and all the other factors that are going on.
Out of curiosity, Nick, because we talked a little bit before the podcast, what source? Because you picked up a very good book, which I'm actually curious about reading one of these days. For those listening and might not know, we do our own independent research, and I think, Nick, you found a really good book, which I really wish for you to share instead of just on YouTube and our sources.
Yeah, so this is a thriller. It's Coral Reef Conservation, edited by Isabel M. Cote and John D. Reynolds. I'm just kidding. It is not a thriller. It's just a textbook, but it had a lot of good information, brought me up to speed, and just a lot of things I had never even thought about. And it was pretty, for someone who had minor to no background on corals, it was pretty easy to understand. There are some things you have to look up, but for the most part, I was able to read it.
Hey, that's always a good textbook if a novice can pick it up and just go. And before we get too far away from heating up, coral has been trying to survive themselves. They've been trying to adapt to the environment. In the past 2 decades, they've naturally tried to adapt to the heat. They've actually tried to be more attuned to the water temperature, but because it's rapidly changing so fast, they can't keep up. So they are trying to evolve and pretty much evolve in front of our eyes, but it looks like they're going to need some help from us in order to survive. And like I said, coral reefs are so important. 25% of all ocean life in some form or matter came or depends on coral reefs. That's such a huge, huge number.
We're going to talk a little bit about another thing that impacts coral reefs and ties into people depending on them, and that's going to be the use of poor fishery practices.
Oh, Nick, before you start, just humans not knowing how to fish, or at least have a sport and matter of fishing is ridiculous. Like, I want to elaborate before Nick continues. Like I said in the beginning of the podcast, an estimated 500 million people earn their livelihoods from reefs. Just want to keep that in mind as we continue. Sorry, Nick. Go right ahead.
You're good. So I wanted to bring up the topic of predominantly third world countries that still use cyanide and dynamite fishing as a means to get their fish. There's also just abundant overfishing in third world countries of, seine fishing, fishing with nets, just dragging along the bottom. But let's start off with the cyanide and dynamite fishing first. So cyanide fishing is predominantly done in the Philippines, where they go down to the reef and they'll find a fish that they want. And that fish predominantly goes to China they eat them live. So I forget exactly what that practice is called. But the Filipino divers will go down in the water, find the fish, predominantly an older fish. They like the older fish, which is, those are the ones that breed. So it's important to leave those in the ecosystem and take the smaller fish if you can. And then they'll find whatever one they want. They'll release a bunch of cyanide in the water. And what that does is it will stun the fish. It won't kill the fish. And then they can swim over, pick up the fish, put it in the boat, sell it to whoever their vendor is. But the problem is that cyanide won't kill the fish, but it definitely kills the corals. And there's a lot of corals down there in Asia, like just a crazy amount. And it's really hampering the reefs. And it's tough to control because the government says you can't do it, and it doesn't matter because they don't have the manpower to track down the people who are doing it and stop it. They got more important things to consider, and they lack the funding to do all that. So this is kind of just going on, unchecked.
I think an important note is countries' borders don't expand that far into the ocean. If I remember correctly, I think it's only like 3 miles until you're into international waters for most countries, or something between like 3 or 15. So not really far. So if they really want to do this cyanide fishing for live fishing, they could just drive their boat out a little bit farther to do it, which is disappointing to think about. Sorry, Nick. Figured I'd add on to that.
No, you're good. And that'll we can transition into management now or later.
I think later, because it's weird how, now I'm all for people celebrating their cultures, but when eating live fish, such as in Japan or China or other Asian countries or other countries around the world that we may not know about from our limited research, it's very devastating the way they are doing it. This cyanide that they're adding to the water is completely disrupting that. You're literally dumping a poison to kill fish and not thinking about where the fish live or that ecosystem where the fish are. And it's just disappointing on the humanity's stupidity. And Nick, you didn't really touch about Dynamite, which I think we should add before we talk about management, is some people are just literally dropping explosives like dynamite into water. Now, when you're in more shallow places where a lot of ocean life and fish live, such as the reefs, and you drop some explosives in there, it's going to be a bad time. It's going to literally destroy the habitat. You're literally putting an explosive on the habitat and not expecting it to get destroyed. And like Nick said, they build upon each other's, like all the way up to like 2,000 years. You're literally destroying up to 2,000 years worth of work. And you expect them to just bounce back like that? It's super destructive. And I don't understand how people can do it. Maybe it's just ignorance. I mean, as we've talked about in previous podcasts, knowledge, we always tell you guys to do your own research, and knowledge is the best tool. And it just aggravates me, Nick, that people are using cyanide or dynamite or overfishing where they're dragging their nets and destroying the coral that way. Sorry, Nick, I just pissed me off a little bit, so I figured I jump in there.
No, you're good. You can simmer down. So I want to bring some numbers back to like we talked about, the live fish market. A natural reaction, one that I had, was, oh, well, why don't we just grow the fish and then sell it to them? No, they don't like that. It needs to be wild caught live fish. For the entire live fish trade in Asia, only about 5% of those fish are grown for commercial use. The other 95% are live caught out in the wild. And the places where the dynamite fishing is going on, predominantly third world countries with minimal education about what they're doing, and they're more concerned about feeding their families, and we can't blame them for that. The areas where people who know the damage they're doing with dynamite fishing, that's different. But I didn't really run across anyone just going around, in like a first world country dynamite fishing, except the occasional Florida man.
Well, good old Florida. If it's crazy enough, they'll do it. And it's I feel like we could do a whole episode just on Florida alone. But like you said, Nick, it's the lack of knowledge and ignorance, and it's literally destructing the habitat, and that is huge. When they don't have a place to eat, to live, or tons of species are dying off, it's horrible for them. And I think it's important to bring it back to the polyps and algae that make up coral. Of pretty much the coral gives a place for the algae to survive, and the algae help give polyps the food. And when you destroy that, or you add a chemical in the water, like we mentioned earlier, nitrogen, or you're literally dumping cyanide, the algae can't survive. And there are occasions where using these extreme unnecessary ways of fishing are causing bleaching, because you're literally poisoning, covering, destroying the environment, and it's causing coral to die. Not just that coral that was directly affected from the poison and explosives, but the surrounding coral, because it's, again, complex ecosystem, which many fish and species survive.
Yeah, and I think now would be a good time to talk about what happens after a bleaching event. Okay, so once the coral's been killed, bleached, and if they just are set, about half the coral, if it's been killed or bleached off, sometimes they recover, sometimes they don't, but for the most part, after a bleaching event, the majority of coral will die, or at least the majority of that population of corals in that particular reef. Well, like we talked about in the wildfire podcast, other plants are going to come in after them, and those plants are algae. When those algae plants come in, they take over that resource, that light resource. They're going to grow over the dead corals. Once that algae comes in and takes over that light resource, it takes over that ground, it's going to outcompete the corals that are there. And it's going to be able to multiply a lot faster than the corals. And once it, establishes itself or has at least 35% of the ground cover, then that coral is going to be, or the reef itself, as the block of land there, all of the organisms and the fish is considered degraded, and you're going to have, I forget exactly what percent, but a lot less percentage of fish there, because they feed on the corals as well, and that food is predominantly gone, replaced by the algae. And there's some herbivores that'll come through and eat that algae, but at that point it won't be at the level to keep the algae under control.
If I remember, Nick, correctly when researching it, that invasive algae, or not invasive, the algae that takes over once bleaching process happen, turns it, that white graveyard, into like a brownish color, if I remember correctly. Do you happen to remember that at all?
Yeah, it just reminds me of I don't know, any lake, like just like kind of algae that you throw at your friends. It's all slimy and it's brightish green, but everything else, the water's kind of got not a gross, but like a brownish tint to it.
I think we are swimming in very different waters, my friend.
That's a possibility. It looks similar to, I don't know, the algae that covers rocks in rivers out here, where it's just kind of, it looks very slimy.
Okay, I think we're talking about the same algae, and if I could be mistaken, please let us know on Facebook or Instagram what your thoughts and opinions on coral reefs, and if I'm wrong at any point. But after the bleaching process and that algae comes in, it turns into like a brown muck field. And Nick, you brought up a very good point, which we didn't cover yet, which I think is very important, is when that reef dies, the entire ecosystem goes with it. So all those fish that were using that as breeding grounds, using it as fishing grounds, using that environment, they all disappear. They all go to a different area or try to find a new home. An entire ecosystem, not just a species, is disrupted and dispersed. That's so weird to think about, how it's like taking a forest and removing all the trees and prairies and grass. Of course, the deer and the raccoons and antelope are going to go to a different area. And it's the same thing for underwater. The coral reefs are a backbone ecosystem of the water. And I can't express how important they are to the ocean and to us.
Yeah, and like we talked about, the depths that coral are facing this, 8 meters or 26 feet, a lot of fish, I don't know, not a lot, but there are fish who need the corals, those shallow coral reefs, next to mangroves, and they'll go in the mangroves for spawning and stuff like that, and then live in the reef. And when you remove either those mangroves or the reefs, they have nowhere to live or nowhere to breed. The coral reefs is a very intricate ecosystem, more so than, say, a forest, where it's pretty easy to recover or relatively quickly in like a geologic scale. But not on a human scale, you wouldn't think of it, but there's usually other areas for these plants to go and animals to go after disturbances compared to coral reefs. It's crazy how intricate all these little relations these plants and animals have in coral reefs.
God damn it, Nick. Where's Dory and Nemo supposed to live when the coral reefs are all gone? Disagree with your statement of small portion of fish. Again, 25% of the fish in the ocean of marine life in some shape or form depend on reefs. That's what the planet's covered 70% in water, and say 5% of that is inland lakes, oceans, rivers that's not ocean. So say that's 25% of 65% of the entire ocean depends on coral reefs. It's just mind-boggling to see like how a keystone environment coral reefs are for everything. And it's sad when, again, I don't think people realize that the coral reefs had such a symbiotic relationship with themselves, like the polyps and the algae. Like, it's a very delicate balance, but there might be some hope. It might not be too late to turn the tide. I was laughing at my own joke. Oh, Nick, you must hate me with all my puns.
First off, yes. Yes, I do hate you for all your puns.
That's okay. Most people hate me. But there is hope. And that makes me excited because scientists are doing hard work, and there's a possibility that we can not only stop these coral reefs, which, again, range from the Caribbean to Australia, so literally the world, to stop them from dying, to bring them back to their full healthy system. Not just stopping the death, but bringing them back. Sorry, Nick, you were trying to say something?
So before you get too far down, there's one more problem we have to talk about.
Oh no, what did I forget?
Tourism.
The tourists.
So I know tourism. So think of reefs like that hip new town, say Austin, something like that. Denver.
You get a pick on Texas, Nick?
Yeah, let's go back to Austin. We're going to choose Austin. I think Denver's a better example, but we'll go to Austin. It was cool, whatever, before everyone moved there. It was this sweet spot. And then people started moving there, and it got bigger, and then eventually it gets kind of lame. And then it's just another big city. Think of reefs that way, okay? You have a reef that's relatively undiscovered because no one's really traveled there. There's predominantly just the locals who live in the area. And this happened off the coast of Egypt is what I'm specifically referencing, but it happens all over the place. So there's not a lot of people there, almost no construction. So what happens first? Well, once people discover it, air quotes, discover it as a travel destination, you're going to have some nicer resorts move in. You have higher income people, more well-educated, and they're going to come and enjoy the reef. But then eventually, after all the construction, and construction is an important part to consider because of countries that don't have the best building codes, a lot of these second, third world countries will let people just, build right on the edge of the beach with no catchment. And a lot of the concrete dust and other debris from construction gets into the water and just tampers with everything. It clogs. It just changes the water quality, just all sorts of bad things to the reef.
It blocks the sunlight. Like we said, algae needs sunlight to survive, and the polyps need algae to eat. Like it's when you affect one, it affects the other.
So you have the construction, which is the primary. It starts the degradation process of that reef. Once that reef starts to decay, then people stop visiting it as much. So what do the hotels do? They lower their prices, build more rooms, get more people there. Once it becomes cheaper, more people come to visit, so they build more hotels. As more and more people come, the income and education of the people coming decreases, and you have less respect for the reef, more damage by humans as time goes on, until eventually it's, a ghost town. It's essentially like a mining boom, but for coral reefs in tourism. And then it'll level out to a certain percentage that the reef can kind of control. It reaches carrying capacity of tourists. And once you hit that point, then, the reef's already been pretty much degraded. It's established a healthy number of people that it can kind of start regrowing with, but also it's still degraded, and the people coming don't tend to be the more well-educated people who are going to care for the environment.
I think it's important to note that not only on fishing do countries and people survive on, but that tourism is huge for majority of the countries. And to protect it, if I'm not mistaken, Australia has closed off a lot of the regions of the Great Barrier Reef to protect it. Because when you start getting some person who does not care, and I'm not saying it's all people or a large portion, but one can do a lot of damage by themselves. But if you have one person who doesn't really care and is bathing themselves in a suntan lotion that's not good for the environment, or simply just throwing their plastic water bottle off their boat as they go exploring, that hurts that environment so much. It's such a delicate balance.
And I think now we can go into solutions. I think we got all the problems out, Mike.
I disagree. I remember a solution, and thank God for notes, because I would have forgot about it. I was waiting for you to say that so I can just prove you wrong. A little you Yankee keep making fun of Texas. I gotta get my glicks in when I can.
How long ago did you move to Texas?
No, numbers are arbitrary. But anyhow,
Well, can't you not be a Texan unless you were born there, or your citizenship has to be granted by another Texan?
Texas is a state of mind and a peace of heart. Now, y'all might not know that up where you're from because you got so much smoke you're breathing in, but down here in Texas, it's a peace of mind. Anyhow, another problem is affecting is the increase of CO2. Now, we talked a little bit about global warming and how the ocean absorbs majority of human pollutions, but CO2 is a particular one that I want to talk about. CO2 has made the water more acidic and has made it harder for the coral to grow their calcium carbonate skeleton. Now, for those a little slow on the jump, the skeleton of coral is calcium carbonate. So it's a bone structure. It's a base, if I remember correctly, calcium carbonate. So when the water becomes more acidic, it tends to cause more problems. And if the coral can't grow, if it can't produce more of a skeleton to get the algae closer to the light or expand so the algae can get more light, produce more food for the polyps, it's going to negatively affect the coral and might even cause the coral's death. So I guess to relate it to humans is, imagine you're growing up as a child and all of a sudden someone cuts out part of your spine and you can only now grow so much certain height. You can only get so much resources. It's that kind of effect for the coral reefs. And when this warm water happens, it starts to accumulate molecules like hydrogen peroxide. And when it leaks into the coral, it stunts their growth, like removing a spine out of a human. It's terrible. This acidic water causes their skeleton to produce like hydrogen peroxide, which then kills the algae and also stunts their growth. And they feed off each other, like adding more fuel to the fire. And it's devastating to them. And we'll talk about it in solutions with perhaps removing acidic sea in water, but simply lowering your CO2 emissions, or the world lowering their CO2 emissions, would greatly help these oceans and the coral reef survive. Nick, I assume you want to jump in here somewhere. I'm more Texan than you.
I heard that. No, I was just actually flipping through my book to make sure we didn't forget any other problems with coral reefs.
It's been a long late night, ladies and gentlemen, so we're this is a little bit of a weird Twilight episode if you talk about it. But since you are not coming up with any solution, any problems that are jumping in your mind, I'm going to talk about my favorite part: solutions. And boy, are we trying to?
Is that a pun on the acid and base reference you're talking about?
Sure, I'll take credit for something I didn't think about. Anyhow, my favorite part: solutions. And boy, are scientists in the world trying to save the coral reefs. People are identifying how important these coral reefs are and how we need to keep them alive to keep our ecosystem on the mainland survive. So scientists right now are trying to breed coral that can survive in these environments. They're literally taking off species that have survived from the bleaching. I think this is a good point to note that not all coral is the same. There are different types of coral. I don't quite remember all the names and types of them, but they come in all different sizes and all different colors, and they're very interesting textures. But scientists are taking the best ones that survive the bleaching process, or say a place got overfished with dynamite fish or got dynamite fishing. They take the ones that survive that shock to their ecosystem and bring them into mainland in these aquariums to grow them, to breed them, to help introduce them back into the wild. Or, worst comes to worst, a tsunami, El Nino comes in and devastates that entire coral reef. They can replant it. And this shows promising. I think that scientists can do it, but I don't know. This might be just a band-aid solution. What's your opinion on it, Nick?
This is probably one of my favorite solutions because I'm going to bring it back to trees, Mike. Yep, I did it.
Can we make a drinking game out of you and trees?
It's what you do after a wildfire, for your crop, and they're doing a lot of the same techniques and genetic kind of stuff that you would do with a tree species, and I think they're just starting, which is the exciting part. You can start your selective breeding phase now and figure out which genetics are going to be best to carry on in these environments with more stress, more heat tolerant species. So they're growing them in a lab and then they're transplanting them. And right now they're still figuring out how to transplant them, what species to put where, all these certain things. And I think we're going to see rapid improvement in the next couple of years. Part of the problem is there's no industry. So like, say for trees, we get paid to plant trees because we'll eventually cut those trees down and turn them into lumber. Who is going to pay to plant all these corals? Is it going to be a tax that the government provides? Is it going to be a government run program? I'd rather see some industry lead the way, maybe simplify the process more. In my book, they said even for, planting corals and replanting corals in a dead reef, they still have to do an environmental impact survey, which predominantly takes anywhere from like 9 months to a year, depending on what agency, where it is, all this stuff. And in that time, a lot of things can change, which would then restart your environmental impact survey, which is why I think this might be better suited for state level. Maybe a portion of this could be paid for by your fish and game tags for your fishing license and stuff like that. And there's tropical states like Florida, their fishing licenses tend to be a little bit more because they have, just a better fishery and they can charge that more. And I know that money goes to really good things, and maybe that's the solution of where to get that from and where to finance it. But the selective breeding, I think, is the most important part because you're seeing a decrease in coral population at an increased rate. And like Mike mentioned previously, a rate that the corals can't keep up with themselves. They're dying faster than they can reproduce and grow. I think we mentioned it, but I'm going to say it again just because I'm not sure. Corals grow at a very slow rate. Some corals grow less than an inch a year, or most corals grow. And in the tanks that they grow them, they can grow, I forget exactly how much, but they grow a lot faster in those tanks because they're in a stress-free environment. They're not competing with other corals. They have all the nutrients they need. And supposedly, once they get put back into the wild, then they grow at a normal rate. What concerns me about that is you can do the same thing with trees. You can take a tree, put it in a greenhouse for 2 years, and you can make it 4 feet tall, giving it all the right nutrients. But when it's not hardened off to the cold that's going to come in nature, or I guess in the coral's case it would be the heat, then it just dies because it has no stress tolerance, which is why I'm slightly nervous about them growing all these corals crazy fast.
Two things. One being I want to talk about stress in a little bit because I think that was a very important topic that we kind of glossed over and didn't talk about more. Secondly is I'm happy scientists are, I guess, taking some coral out of the water and protecting them on land. It's almost like for lack of better words, a back catalog of coral species to make sure in case there's a devastating impact to their environment, we can at least somewhat bring them back, or at least that species isn't completely lost that environment. And to further on what Nick says, yes, we can grow them at a much better rate on land than in the ocean, but to me this is promising. It's less concerning. To me it's okay, a problem happened where say 25% of this coral in this area got devastated. Well, we have enough coral inland where we could rapidly grow that, and that coral rapidly grows to a point where we can reintroduce it into that native environment. Now, again, I feel like this is a band-aid to the solution of there's a hole in our ship and we're just plugging it in to stay afloat, but it's something. Now, to go back to the first point of stress, I want to very elaborate on how this ecosystem is intertwined again. Stress can kill these coral. Now, having a dynamite drop on them, cyanide, having warmer water temperatures, having a bleaching process creates stress for this environment, for these corals. And when the coral is stressed, it's more susceptible to diseases, just like how humans are. And this can lead.
Or just like how trees are, as referenced in the wildfire podcast, we went pretty in depth about stress.
I hate you, Nick. I hate you. Anyhow, with stress leads to disease, and it's important to think about how stressful. I can't imagine how stressful it is for coral right now in the water, and all these things impacting them: overfishing, warmer climate. We're just poisoning them with like water runoff from fertilizing farmlands or suntan lotion or plastic. It makes a stressful environment for them, and it's important to think about. Now, unfortunately, I didn't do much research into that, but again, it seems like coral reefs are getting hit from left and right and every other direction. They're having a lot of problems, and it's hard to focus and just choose one, but scientists are trying. Another process which scientists are trying to do is they're 3D printing structures, which I love as a man who loves 3D printing and does 3D printing quite a lot, to help jumpstart the coral growth. Like Nick said, in the wild compared to inland and lab areas, the coral can grow better in lab than versus in the wild. But with these 3D printing structures, it helps the jumpstart the coral growth. So if you add a baby coral reef, I actually don't know what the name of a young coral reef is called or if it has a name. But anyhow, if with these 3D printed structures, it helps jumpstart it. Now, some of you might be familiar with countries or cities sinking boats to help jumpstart the coral reefs, or airplanes. They use other structures. But this company I want to give a shout out to is a combination of a company called Coral Maker and Autodesk. Now, I have a lot of familiarity with Autodesk. I use Autodesk all the time for 3D development and CAD software. So shout out to Autodesk. You guys are doing good work. And shout out to Coral Maker for trying to make an ecosystem in the water to help jumpstart these coral reefs. Now, I probably rambled on a little bit. So, Nick, I'm going to jump it back on to you.
Yeah, so I ran across these guys as well, 3D printing corals, and it seems pretty cool. They're doing different experiments to figure out what shapes the corals prefer so they can have, everything down to a science. It's pretty crazy.
It is crazy, and I love 3D printing. I will always encourage people to 3D print. So when I see 3D printing helping the environment, it brings some happiness to me. I'd be very curious because I don't know what filament they're using to 3D print. I just want to make sure. I assume it is, but the back of my mind is curious of, is that filament biodegradable? Is it safe for the environment? Is it going to poison other species? I imagine they've done tests, but it is something I just want to bring to people's minds. And speaking of crazy, Nick, I got another crazy idea for you. So we mentioned how warm water is negatively affecting the coral reefs. And again, coral reefs are pretty close to the surface of the water to help, the algae produce food for the polyps. And so they're more towards the surface, so they get a lot of sunlight. They're a lot more towards shallow end, so they might get more affected from other heating sources that could be besides the sun. So I have a crazy solution for you. I love crazy solutions, and I'm always advocate for crazy solutions. I'm probably crazy myself. So I want to run the idea to you about pumping deep ocean water into coral reef areas to help cool them off. Like, get that water circulating a little bit to help regulate the water temperatures. For those who might not know, the deeper water you go, the colder it is. Unless you're by an underwater volcano, then it's hot. It's very hot. So, Nick, how do you like my crazy idea? Thoughts, concerns, opinions?
I love that idea. I was going to bring it up because, so like the first was it the first or second ice age, was caused by a change in ocean currents, bringing predominantly colder water up. And I kind of was thinking about that. I was like, wait, why don't we just do that on a smaller scale? We bring some of that colder water up into the coral reefs, cool everything down there. This is being done inland in, say, California, anywhere there's dams. Californians use a lot of power, they have a lot of hydroelectricity. Another advantage of that, all those dams, is the water that flows downstream is very cold. It comes from the bottom of the lake, and that cold water is great fish habitat. Now, a saltwater dam would be hard because you don't have salt water that you can dam up and flow into the ocean. You'd have to pump it into a reservoir and then pump it out once it cools down. I think it'd be easier just to kind of redirect some of that cooler water up in certain places at a smaller scale.
So how I was thinking in my mind is literally just an underwater pump, maybe, I don't know, to produce much gallons, should probably be the size of a shipping container, into a coral reef kind of area. And hopefully this reef would have a both patch reef, barrier reef, and fridging reefs. And I apologize for those listening where I keep using barrier reefs. I use that word quite interchangeably between barrier reefs and all the other reefs. It's just how in my head it works is classifying reefs as barrier reefs. It's not true, but it's just how I do it. But anyhow, having a water pump literally just sunk to the bottom of a curve or a hill underwater and pump the water up. I mean, it'd probably be an expensive project, and I want to point out, Nick, small scale versus like ice age scale, that's a large range of what's considered for small scale.
Well, that's what gave me the idea. That's where the thought came from, is the moving of the plates, they believe, caused the ocean currents to shift, moving the water up. So because of that, I wasn't thinking pump. I was thinking more like some kind of structure of ramp, if you will, that goes down into the current and then just pushes it up almost like a ramp. Well, exactly like a ramp. And that current has that pressure behind it. It'll just be moved upwards towards the reef instead of continuing to flow circular around whatever current it's going on. Basically just like an off-ramp on a highway that's built. Right now the current is that highway and it's going around and around, and then you build a ramp to get off and then shoot it towards the reef. Is kind of what I was thinking, a more permanent structure, but one that doesn't require power or anything along those lines. It's once it's there, it's going to be there as long as nothing comes and breaks it.
You did make me just think now of a curious idea. So I'd be very curious to know what the currents of the ocean are that are related to these reefs. Now, is the water always coming in? Is it always near? If we could, like you said, introduce a structure, for me, I'm most thinking of the Pacific Ocean with El Niños. If we could make a structure, a barrier to break that water up so the reefs don't get hit with the warm water of El Niños or some other source of warm water, I'd be very curious to see what the impact is of having that physical barrier. And water currents themselves is a whole science, so I imagine that has a great deal to play, and I'm not quite sure how much humans can control that. I should definitely do some more research into humans controlling water currents, because that'd give us a great tool and power to help the coral reefs.
Yeah, and that would be a more permanent solution, longer to put in place. More temporary solution, which we talked about, would be some kind of shade, like we talked about, how the corals that are exposed to more sunlight are the ones to die or at least get bleached. If we could put up some kind of shade that cools the water as it comes through, or just similar to the ponds in California, they put the ping pong balls in that reflects some of that sunlight away, that cools everything down. It might just bring the temperature down just enough to where those corals can survive.
Yeah, it's not a terrible idea. The only major wrench in that engine is the size of a lot of these reefs. But if we could come up with a solution of, I don't know, a floating barrier on the top of the water that still allows some sunlight in to allow the plants and the nature to eat, but just keep the water down, the water temperature down, that'd be huge. And I don't think people realize how different having 1 degree or just a little bit cooling or to cool down these areas, how huge of an impact that is. Imagine you're feeling 1 degree or 2 degree warmer. You might feel a little bit discomfort. For some people, it might be the start of a fever. It makes a huge difference, just that little degree change. And Nick, I think that's a good solution that, with the right scientists and engineers, could be very possible.
Yeah, and a smaller scale, not that we would put across the whole reef, but I don't know how this works for reefs. I just know for fishing, out here on the coast, you have areas where the water will come in to the shallows and then areas where it will drain out. If you just targeted those areas where the water is coming in, that might be enough to just lower that water, because that if that's going to be colder as it comes in, once it gets there, it might heat up a little bit, but you've already cooled down your incoming water. That way, your structure is going to be a lot smaller, have less impact, not create a micro ecosystem underneath it or on top of it or around it. Or it will, but not as large of an impact as if you put a structure across the entire reef. So that might be one kind of solution.
Hey, something's better than nothing. An inch is an inch. It all adds up. And like you said, small areas. It made me remember of a possible solution that people are talking about. There's no real implementation of it, but it'd be changing the sewer systems that lead into the water. So the runoff of the fertilizers or other chemicals or plastics has to go through a more filtration system before reaching the water. So it might lower the acidity level of that water. It might allow less foreign chemicals or too much of one chemical getting to the water. Now, I imagine that's probably a very expensive project because you're going to have to do it to, God, so much coastline of where humans meet the water source. I mean, isn't it like 60% of all humans live near some body of water? It's a high number. It might be even higher than 60. So to do that on a large scale for everyone near an ocean, it might not be possible. But again, an inch is an inch, and every little matters. Switching it up a little bit. Speaking of every little bit matters, I want to talk about a certain company from Ranger Bots. And from this company, Ranger Bots, come a type of robot slash drone that is called larva bots. And these are drones to use to help and spread millions of coral spawn. And I love that idea. I like robots. I like drones. I'm a mad scientist in the making. So when I hear millions of coral spawn can be helped from larva bots, and we can make it automated, so we can get to all these areas that might be far away from humans. So a lot of these like reefs that we probably didn't mention in the beginning are away from major cities. Like they're kind of out there a bit farther away from civilization. So these robots could lower the cost and perhaps help us all. And Nick, I know you like drones as well. What's your thoughts and opinions on this?
Many hands make small work, right? So if we can get these drones out there doing these things, it'll lower the cost for, you don't have to have humans do them, and it might be something that just, as the technology increases, it's only going to get cheaper. So it might be something that we just have doing full time, like a little cleanup crew.
Yeah, and imagine if we could dual purpose these drones to not only plant these coral spawn, but to clean up plastic that they see along the way, or maybe somehow lower the acidity of the water, or this is probably not practical or possible, but lower the temperature of the water. I'm off the top of my head, I can't really think of a way to do that, but if they could plant these coral in these remote locations and maybe help clean up the problems such as suntan lotion and plastic and other acidities that our humans cause, that'd make a huge difference. Just to have a bunch of little robots taking care of these coral reefs where all this life, all these possible new medicines, all these amazing creatures can survive and have full, healthy lives. And I think that's what a lot of people want.
Another thing that they could do, and I mean, we could do, like we talked about in invasive species with assisted migration, if the earth is getting, or the water's getting warmer, we just got to move some of the corals more north or south, depending on where you're at. And that water should be, more akin to what they're historically used to. And maybe corals don't move that fast, but with a little help from humans, they might be able to colonize some of those areas. So we would still have the same number of coral reefs and same number of fish. They'd just be a little bit farther north or south than they were before.
Water's getting warm, so might as well swim. Little Smash Mouth lyric for you. But I don't know about assisted migration. That's a personal ethic dilemma for me. Of yes, species commonly move and don't move. So, but they usually don't move without they just usually move on their own, not with human intervention. But if it's a human problem, maybe it causes for human intervention to fix it, such as assisted migration, which that is a interesting problem or solution for me. That just the back of my mind personality things. But it has been affected with other species on land. I'm not sure if there's been any species that has done it with human intervention in water. That I'd be very curious about. And Nick, I think you came across the same study of acoustic enrichment can enhance fish community development on degraded coral reef habitat. Whew, that's a long name. That's what it's called if you want to look it up yourselves, ladies and gentlemen. And Nick, before I jump into it, did you hear about this study with acoustic helping the coral reefs?
Yeah, so what they're doing, is playing the sound of a healthy coral reef. And it's hard to describe it, but if you've heard it, you know it. It just sounds like a lot of scraping and pecking. It's the sound of fish biting coral and picking food off the bottom. And so they play that so fish hear it and say, well, it sounds like there's a bunch of fish over here. There must be a bunch of food over here. If they're feeding, we can feed. So it attracts more fish and you increase your fish population.
Yes, that was kind of a weird way to explain it, but here's a little bit more layman terms. Pretty much scientists put giant speakers underwater and played a healthy coral reef system or a reef system to be like, hey, this is normal, la 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 la. So other fish come back, and hopefully that would jumpstart the reefs coming back and adding more creatures to the ecosystem to help it more ecosystem. And Nick, I personally got to say, this is absolutely crazy idea, and I love it. Just giant speakers underwater to play sounds for fish to help the coral. It sounds absolute crazy, but crazy works. And to play onto that, the proof that it works from the study, which I don't want to pronounce again because it's a mouthful. It has helped double the amount of fish in the area, and has increased the number of species type by 50%. Now, this might necessarily mean it'll stay that way or the coral will come back, but some progress, I guess, is better than no progress. Nick, thoughts, opinions, concerns?
Yeah, my main concern is that, like you mentioned, it's a temporary boost. You're getting all these fish here because they think there's food, but sooner or later they'll realize there's not food and leave. I think this is a great tool if accompanied by some kind of habitat restoration, planting of corals, or something like that that increases the amount of food there, because eventually those fish are going to get hungry. And if the ecosystem doesn't have the resources to support all those fish, some fish are going to leave, some will be pushed out, and some might just die. So I think it's great to know. And if you have an area where you want to bring fish back and you have a healthy ecosystem, you can't get your population up, that might be the way to do it.
Maybe we can combine a bunch of solutions that we just said. So scientists create a 3D printed environment to jumpstart the coral. They take coral that has survived and the scientists are growing on inland and place them in there, and then they have the robots, the drones, implement other new spawn, and as scientists and engineers grow that environment, have the speaker to play that healthy sound to attract more fish. So it's kind of a introduced non-natural ecosystem to turn it natural, if that makes sense. What's your opinions on that, Nick?
Yeah, I think that's your best case scenario. You need those resources there for the fish to eat before, you bring those fish there. So with the planting of the 3D printed corals and stuff like that, and then you're just bringing all those fish back, you're advancing what would normally naturally take years. I just say my only concern is if someone leaves the speakers on shuffle, what could happen?
Get some Tupac playing underneath water. But another solution, which I didn't really see much come across it, was bioengineering algae. Now, it feels like almost every episode we talk about bioengineering and CRISPR, such like that, and it's a powerful tool. So it's tempting to use, but scientists are growing coral on land and taking the healthiest ones of them. And like we said, it's a very symbiotic relationship. Coral provides the home, algae help provides the food. So, and we also mentioned with bleaching, if the algae doesn't come back, the coral dies. So why not bioengineer the algae? Why not make that algae a little bit stronger against heat and other contaminants from humans to maybe even stop the bleaching process from happening? Or better yet, if a bleaching process does happen, introduce this bioengineered algae to a bleached coral area to help bring the coral back to life. So the natural algae couldn't survive. I'm not going to pronounce it again. I'm going to just call it the zoo algae. That algae cannot survive warmer waters, but the human engineered one can. So maybe cheat a little bit with this bioengineering. And Nick, I'd be very curious. We've talked about bioengineering the coral, but not the algae itself. How do you feel about that?
Well, I think that's, where you got to start, because the coral structure isn't what's dying, it's the algae inside. So if you can make that zooxanthellae more heat resistant, then your coral is going to be fine. So the problem is sometimes all those algae are different. Sometimes different algae in the same coral. So there's a lot of diversity going on. So that's what's going to be more of a challenge.
Interesting. See, when I saw them, by them I meant scientists, of them bioengineering, I saw them bioengineering the polyps so they can continue to build and such when other negative things happen to them. I didn't see much on the algae, but it makes sense that it'd be majority of the algae that scientists are focusing on engineering. That makes a lot of sense hearing it out loud. But you are right. This is a very diverse and complex system. So I'd be very curious on how many types of algae are intertwined with the symbiotic relationship with these polyps. Like how many actual algae are necessity for these coral reefs or these reefs?
Yeah, that's a good question. I'm Googling it right now.
Well, while Nick Googles, again, I don't think as any problem that we bring up on any of these podcasts that one solution is the best solution. I think definitely adding a large variety of solutions is the correct way to do it. Now, we've kind of skimmed through and talked about different subjects. It's hard to cover everything in depth in a short amount of time. Coral reefs are complex organisms, and it's a problem that we're dealing with of them disappearing. And I really hope they don't disappear. I mean, countries are already closing off them from tourism and other fishing areas, and because they don't want to lose them. And I'd be devastated to lose those in my lifetime and any lifetime. I want those to last for eons upon eons. They've lasted 40 million years. Why should they end when humans finally come along? So hopefully they survive, and hopefully we cause the problem. Hopefully we can fix the problem. And it's not like coral's not trying themselves. We've mentioned earlier in the podcast that coral is trying to adapt. So maybe we're the booster shot. Maybe we just give them a little help, and that'll be enough. And again, we can help in so many different ways. And us as individuals, like we mentioned, the sunscreen, the plastic, the water, the education, just knowing that coral reefs are being negatively affected. And there are great organizations out there working to do it. And then bravo to the scientists who are trying to keep coral reefs alive, and scientists who are growing coral reefs in case the worst of the worst happens and an entire species of coral goes extinct. And Nick, I'd be curious, did you happen to find how many algae are in the coral reefs?
Nope. All I could find is that there's 6,000 different species of coral. So it's a pretty high number. It's hard to
6,000?
It's going to be hard to breed back all of those species, and the land on the amount of land on actual land it would take would be pretty impressive, but we'll figure out. I mean, probably not all of those are being hardest hit. The ones being hardest hit are those shallow water corals.
Yeah, that's a good point. The again, closer to the surface, the warmer it is. So water's getting warm. Might as well swim. Bring back Smash Mouth for y'all. I'm a '90s kid and figure do it. But I'd be curious to hear any other solutions. The coral reefs, the reefs in general are very dear to my heart. They are absolutely beautiful. I can't stress enough for everyone to look up and just see the beauty of coral reefs. You might see them on like documentaries, but just to actual look at a photo of real coral reef, it is jaw dropping, and I'd be so sad if those disappear. So if you think we missed anything or you have different solutions, please let us know.
There's one thing we didn't talk about yet.
Oh no, I forgot something.
So we didn't talk about human response. So there's things that governments can do, laws and such, groups that can maintain coral reefs. And they've been shown to help even in second, third world countries. So a lot of these times, these areas are called marine protection areas, commonly just MPAs, and they differ for each area because, like we mentioned previously, all the coral reefs are different. So you can't put the same way to measure a healthy reef on all these different kind of reefs, even reefs that are on the same island just far apart. They might be made up of entirely different corals or different keystone species of fish, whatever it is, different predators, things that survive and breed there. There's so many different ways that differentiate these and to tell whether they're healthy or not.
I did not come across that, and Nick, I'm very happy you brought that up. Like I mentioned, we do our own independent research, and I did not come across that. I'm happy you brought that up. Again, bravo to the men and women who are working literally on the front lines to help these species of 6,000 species of coral stay alive. That's so much diversity. I'm still trying to get over that number, 6,000. That's absolutely amazing.
So some of these areas are complete no-goes, or for the most part are complete no-goes. But these same people who govern these marine protected areas are usually some kind of fish and game, also responsible for the rest of the areas that are in trouble. And they won't make those no-go areas. They might have limited access. So you can snorkel if you're above or in water deeper than 20 feet or stuff like that. And that's to stop people from their fins hitting the reef or their sunscreen getting on, stuff like that. They've implemented, if it's a beach that you walk out onto the reef, like a big floating dock, so people don't walk over corals. And a lot of what they do is a lot of these marine protection areas in like second and third world countries are more to protect against overfishing. And those agencies have found that almost more important than protecting that ground and keeping people off of it, education of local fishermen is the best way to stop like we talked about, education is one of the main problems, is to stop the destruction. Once these fishermen are educated in the fact that if you catch all the fish now, you won't have fish later, in simplest terms, for the most part, they really haven't had a problem. I mean, you're going to have bad apples in every bunch, but these guys who are going out, protecting these areas, educating the people around them, are reducing a lot of the human impact, or like not the wider scale non-point source pollution, but the point source pollution that can be easily identified problems.
Seems like having your cake and eating it too, of yes, you can swim in these areas, but with these rules and regulations. And I'll be honest, with how dire the situation is for coral reefs, I'm okay with that. It's if we can implement simple rules of, hey, you can't go swimming unless you have so-and-so sunscreen or sunscreen without these chemicals, or no plastic, only renewable water bottles on the beach, or no dynamite fishing or cyanide fishing, which I still can't believe people are doing. It's just simple stuff like that can make a huge, huge impact.
One of the problems that these marine protected areas, like I talked about, is because they have such a diverse resource they're protecting, it's hard to get a metric of how successful they're being. And when their parent organization can't be shown how the good they're doing in numbers, it tends to kind of go by the wayside. And the problem with that is, like we mentioned previously, the metrics for all of these are going to be different, so it's hard to compare. When you make things hard to compare, it's hard to allocate money because say it's the United States and the feds are given, $5,000 to whatever reef protection agency is in dire need of it. And Reef A says that their, trumpet fish population is down 20%. And Reef B says that 15% of their corals experience coral bleaching. How are you supposed to compare those two? They mean nothing.
Yeah, when you're talking about an area so large with such a device species, I can't even imagine the numbers that they're trying to calculate or how complex it would be to get an accurate reading of how that environment's doing. But again, an inch is an inch, and all inches add up. And I'm very happy that that organization exists and people are trying to keep that ecosystem alive.
Well, I think that's the end of our show. There's one thing I think we need to mention is we really talked all over ourselves today, and I think, now this is a hypothesis, and I haven't come across this in my research, Mike, but do you think increased consumption of alcohol can lead to slurring of words?
I want to disagree with you so badly, but I bet you'd be very right.
Anyway, if anyone finds any research on that, let us know. And before we close out the podcast, I want to give a shout out to my mom. It's her birthday, and she's the one who got me reading Clive Cussler and got me into coral reefs. So give a shout out to Gretchen.
Happy birthday, Gretchen. And Nick, where can they find us?
They can find us on Instagram at Backyard Philosophy Podcast, and on Facebook at Backyard Philosophy Podcast as well. We are not on Twitter because it's a dumpster fire, and we can also be found on YouTube, which is where our sources are.
Awesome. I'm so happy. I love the dumpster fire every time, Twitter. Well, thank you all for listening. Again, we were kind of all over the board there today. I hope you enjoyed it, and we'd be very curious to hear your opinions, thoughts, and ideas, and any personal shout-outs to anyone helping the coral reefs. Please, just let us know. And thank you all for listening.
Thanks for listening to the Backyard Philosophy Podcast. We rarely finish a podcast without missing a point we wanted to bring up, so let us know what we forgot. And if you have a topic you want us to talk about, let us know at Backyard Philosophy on Instagram and Backyard Philosophy Podcast on